All right, hello once again. Now to the meat of the day. All right, I have a great news for you, and that is that everyone in here has the opportunity to get some extra credit. All right, and this extra credit is so easy to get. And so you should be thinking about how can I volunteer to get this extra credit, because it is easy. As a math teacher, there are just once in a while, there's some times where we're working through a problem and maybe my brain is just not seeing it the way that I'm supposed to. And so I don't even always have to know the way. I could turn to the students and say, hey guys, what are we supposed to do next? And the students will be able to go, oh, well, we should do this, that, or the other thing. And I go, great. And then that makes me go, yep, that was right. And I can get my brain back on track. But once in a while, we all have that off day. And so right now, I say that because you can volunteer and you don't have to have all of the great skills. You just have to be able to ask the right questions. If you are willing to step up and stand in front of this class and ask the students of this class some questions, you can earn some extra credit. It's this easy, all right? I have a proof right here. This is not the proof that you're going to do, but what I'm going to do is I'm going to offer, Ms. Avent can take a volunteer real soon. And if you're volunteering to step up to this board and to work out a proof. That's very similar to the one that's right here. Now, the good news is you don't have to know how to do it. You could be the worst student in this class and not know anything about proofs, and that's all right. What you just need to do is you need to be able to step up, stand in front of the class, and ask, what should I do next? And what should we do next? And what should we do next? Okay, keep it simple. So let's think about this proof. If I was there, or if maybe we had a volunteer stepping up right now, you could say, hey, first of all, let's think about how are we going to prove these two triangles to be congruent? What shortcut are we going to use? And as I look at the situation and realize that I have vertical angles here in the middle, I would know that I'm going to do side, angle, side. Side, angle, side. Okay? So I'm going to do side, angle, side. All right, that's how I'm going to prove these two triangles to be congruent. And so maybe I step up. If I'm the volunteer right now, I could ask all the students that and say, hey, look at this picture right here and tell me, how do you suppose that we're going to find these triangles to be congruent? And I'm thinking that someone is going to be with it enough to go, oh, we could do side, angle, side. And you go, great, let's do that. And so if we're going to do side, angle, side, the first thing I do is I'd say, where do we want to start? And someone would jump up and say, well, we could start by saying, that first bit of the given right there, that side AB is congruent to side CB. How do you know that's true? Given. Great. Okay. Now that's our side. Let's talk about our angle. What angles are we dealing with? Well, we can't call this angle B because there's too much going on at point B, but I can say that angle ABE is congruent to angle CBD. And how do I know that's true? And someone would say, well, because vertical angles are congruent. Great. And then lastly, what's going to be the other side? Well, it's going to be the other part of the given. I bet someone would jump up and say. And so again, if you're the volunteer, you just have to be willing to ask the right questions. Turn and look at the class and say, what do you suppose we should do next? All right, and so what should we do next? Well, we should probably say that EB is congruent to DB, and that was given. And so then we can conclude at that point, right here, that triangle ABE is congruent to triangle CBD. And how do you know that's true? By side, angle, side. We showed it that way. Right here, side, angle, side. Okay? And so to get the extra credit today, what you have to do is you got to be willing to stand in front of this class. And when we pull up a page on the Promethean board, you're going to be able to write on it. You have to be willing to ask the right questions, and you have to be able to fill out a proof like this using the class's help. All right? As the proofs go on, they are going to get a little bit more challenging. The first ones are going to be the easiest, and the last one is probably going to be the toughest. So you can just kind of keep working through it. All right. I hope that's encouraging. And so at this point, we can take the first volunteer, and we can get started. So we can pause the video right here, because what I'm going to do is I'm going to follow up. After we have you, a volunteer, and the class work through it, we're gonna watch gonna continue this video to see how I would do it real quickly. I'm sure we probably do it the same way. Maybe we switch up some steps, no big deal. But I'm just gonna, so that way everybody's on the same page and we're positive we're all doing it right. Okay, so we can take the first volunteer and pause the video right here. Okay, and so now at this point we are back to see how that first proof is going to be done. Well, that first proof, man, whoever volunteered, and I don't know who it was, but they got an easy one. Okay, this has got to be the easiest proof. Why? Because everything is given. Okay, and so all you had to do here was say, well, how am I going to prove those two to be congruent? By side, angle, side, side, angle, side. Okay, easy. So where am I going to start? Well, I'm going to go through this. I'm going to say, well, side AB is congruent to side XY. That's given. And then angle A is congruent to angle X. That's given. And side AC is congruent to side XZ. That's given. And so lastly, I get to say that the very thing I'm trying to prove, that triangle ABC is congruent to triangle XYZ. Why or how? By side, angle, side. Okay? Now, please understand that you could rearrange these steps. These steps could actually be in any order. You don't have to. I like to do it in a way so that it shows side, angle, side. I like that, but you don't have to. Your order could be completely different. You could have these all jumbled up. The only super important thing is that this right here is your last step. You can't say that up here. That would be wrong, okay? But you can list these steps in different orders. As long as you have concluded at one point a set of sides, an included angle, and another set of sides, then you're good. Okay, so hopefully that first volunteer rocked out some extra credit. Miss Avant's going to keep track of all the names, and I will be providing the extra credit. So we can pause the video here and see who our next volunteer is. Okay, hopefully you were pretty excited that you didn't get as easy of a proof, but pretty close. And again, remember, if you're volunteering, all you have to do is ask all the right questions. Okay, when I look at this situation, I see that I've got congruent side, congruent side, congruent side, congruent side, and then they share a side. So clearly, these two triangles are going to be congruent by side, side, side. Okay, so I'm going to walk right through that really briefly. Okay, so I would say, well, I know that side AB is congruent to side CD, and that's given. I know that side AD is congruent to side BC, that's given. And then the tough one, ooh, so tough, but I'm sure everybody in here got it, is that side BD is congruent to side BD. And that's the reflexive property. Something's congruent to itself always by the reflexive property. Okay, now please understand, the person who did this, the volunteer, you could have put these in any order. These three steps can come in any order. The only thing that matters is that you do have these reasons lining up with them. Okay, obviously AB is not congruent to CD because of the reflexive property. That would be wrong. But otherwise, you can have these steps in any order. And then we close it out by saying triangle ABD is congruent to triangle CDB. And how do you know that's true? By side, side, side. Okay, so one more volunteer, got some extra credit. Let's see who's going to go next. We can pause the video right here. All right, and we're back. And as you see, the proofs are getting a little bit more challenging. This one, hopefully you notice right away, we had parallel lines, and every time we have parallel lines, we know something about angles. And so in this situation, I know that this angle right here would be congruent to this angle right here. Those are alternate interior angles of parallel lines. Sometimes some people think that it is this angle and this angle, but that wouldn't make sense because those don't even touch the parallel lines. Here's my parallel line coming through, and angle DAC, like I've highlighted here, angle DAC doesn't even touch that parallel line. And angle ACB doesn't touch that parallel line either. So those aren't it. Those are obviously not it, okay? What we want is these two angles that I have highlighted in blue. All right? And so those would be congruent because these two sides are parallel. All right? And then these two sides are congruent. And then clearly in the picture, we can see that they share a side. So that side's congruent to itself by the reflexive property. And oh my goodness, once again, we have side, angle, side. Side, angle, side, okay? And so I'm gonna go through it real quick because I'm sure you guys did it already. So I'm gonna say, well, I know that side AB is congruent to side CD. I know that because that was given. And then I want to talk about those angles. I want to say that angle DCA is congruent to angle BAC. And I know that because if lines are parallel, then alternate interior angles are congruent. Now, as I've said before, you cannot say that unless you've mentioned that we have some parallel lines. And so on the previous line, I would have to say that other part of the given, say segment AB is parallel to segment CD. And that was given. So this is one thing that the order does matter. This step right here has to go before this step right here. Excuse me. We have to say that they're parallel before we can get that those two angles are congruent. All right, and then we're to the shared side. We know that side AC is congruent to side AC by the reflexive property. Something is congruent to itself always by the reflexive property. And so now at this point, look at what I have. I have done side, angle, side. And so I can say now with certainty that the triangle ADC is congruent to triangle CBA. ADC, CBA by side, angle, side. Okay, 3 proofs down. Let's get that next volunteer to try to do the next proof. We can pause the video right here. All right, we're 3 proofs in. Now let's check out this 4th one. Not that this one is harder, but I'm just trying to bring in at least some new ideas or things that we haven't yet seen in other proofs. Okay, and so in this one, we do clearly once again have some vertical angles. So this angle right here is congruent to this angle right here. I don't know if that can even show up. But so what I'm saying is that this angle is congruent to this angle, okay? We have that this other angle is congruent to this one down here, and then we have a set of congruent sides. So obviously we're gonna have either angle side angle or angle angle side. And so all we have to do is look and see where the side is located. It is located not in between the two congruent angles. Okay, if it was in between this angle right here and this angle right here, then I'd say angle side angle. But it's not. The side we have information about is after. So this is going to be an angle angle side situation, which hopefully you all already figured out. So let's go through it. Now, if I'm going to do it by angle, angle, side, then I'm going to kind of do it in the order of angle, angle, side, of trying to look and just work my way around the triangle. So the very first thing I do is I'd say that angle J is congruent to angle L. That's given. I would say that, and then I got to do my next set of angles, and it's the vertical angles in the middle. Angle JKM is congruent to angle, let's see, JKM is congruent to LKO. LKO. Why? Because vertical angles are congruent. And then lastly, the set of sides. MK is congruent to OK. That was other piece of given information. And so now I can say, because I have shown right here, by angle, angle, side, nobody has to write that. That's not mandatory. I'm just trying to show you. So I know that triangle JK M is congruent to triangle LKO by angle, angle, side. Okay. All right, 4 proofs down, 3 to go. Make sure if you want extra credit, make sure you're volunteering. We can take the next volunteer next or now and pause the video. Okay. Now that we're back, let's take a look at this one. Ooh, this is a curveball. I'm curious to see how many people are going to do this right and how many people are not. Because, see, we just came off that big hypotenuse leg theorem kick. And so when people see right angles, they automatically go, hypotenuse leg theorem. Except that doesn't work for this. Why? Because I don't have congruent legs. I do have congruent hypotenuses, and I do have 2 right triangles, but I don't have 2 congruent legs. So this cannot be a hypotenuse leg theorem situation. It's just not. All right, what do I have? Well, I've got an angle right here, an angle right here, and then a shared side. Angle, angle, side. That's what I have. Okay. Now, the only weird thing is I was given right angles. And so it's going to take a couple steps for me to show that this angle is congruent to that angle. I don't just get to come out right and say it. So let's try it. Okay. This might have been a little bit more challenging one, but how I would have started is said, well, angle D, let me change that up a little bit. What I want to say is that angle D is congruent to angle B. And my reason would be that all right angles are congruent. However, to say something about right angles, like I've done right here, I need to mention that I have right angles. So that's where I go back to this given. And that would be the first step. Angle D and angle B are right angles. And that was given. Okay? Angle D and angle B are right angles, given. So then I can say angle D is congruent to angle B, because all right angles are congruent. Okay, great. Move on to the next set of angles. Angle DAC is congruent to angle BCA. That was given. And lastly, AC is congruent to AC by the reflexive property of congruence. And so now, by angle side, I can say, oh man. I can say the two triangles are congruent. I don't know if you noticed, but I've got a serious typo right here. But you can say triangle, let's see, triangle ADC is congruent to triangle, if I say ADC, the other one's going to be CBA. Okay, and how do I know that's true? By angle side. Okay, I'm sorry I didn't catch that I had a typo on this page right here saying that it wants me to prove two sides are congruent. That's something we're going to look at very soon, but we haven't mastered that yet. Right now we're proving triangles to be congruent, and so that's what we did right here. Okay, we got just a few to go, not very many, so let's take the next volunteer and pause the video right here. All right, let's go. We're going to look at the next one. And here we go. And man, typo again. Are you kidding me? Okay, I don't want that MA is congruent to K. I mean, I do. I want you guys to get there. We're just not there yet. So in this situation, I want to prove that triangle AMD is congruent to triangle AKD. That's what I want. Okay. Now notice this gives us a whole new little curveball here. We're talking about something that bisects some angles. Now remember, to bisect something means to cut it into two congruent pieces, two pieces that are the exact same size. So for this one, if this angle right here got bisected, angle MDK, then that would mean that this is the same size as this. Those two angles are now the same size because the larger angle MDK got bisected. And if angle MAK got bisected, well, then that would mean that this one is the same size as this one because the larger angle MAK got bisected. Okay, and so that's where that information leads us. I don't know if anybody was able to do this one correctly or not, but hopefully. So then we go, well, how am I going to do it? Well, the last piece of information is they share a side right down the middle. So this is going to be an angle side angle situation. All right, well, let's give it a go. So I'm going to say that angle MDA is congruent to angle KDA. And how do I know that? Well, that's the definition of an angle bisector. The definition of an angle bisector is something that cuts an angle into two congruent angles. But to mention an angle bisector, I have to then already have said that. So I've got to go ahead and go back up a step and say segment AD bisects, and I can list both of them, bisects angle MDK and angle MAK. And that was in the given, okay? So I got, well, this one angle was bisected, so therefore I got two congruent angles, definition of bisector. Now, so that's angle. Now let's move on to side. So I'm going to say, well, side AD is congruent to side AD by the reflexive property. All right. And then let's see here. Then at this point, I would say angle MA. Oops, sorry about that. let's see here, angle MAD is congruent to angle KAD. Excuse me. And the same reason, because definition of angle bisector. Now, this should all be review. You've already done this probably, right? And so now I get to say triangle AMD is congruent to triangle AKD. Okay, by angle, side, angle. Now, of course, these steps, we can switch the order a little bit, but however, this step right here has got to be said before I can say anything about these other angles. Okay, it has to be said first. And so just for reference sake. All right, we finished one more. Let's get the next volunteer to rock out this next proof. And we can pause the video right here. All right, and we're back. And here we are. I think, is this the last? Yeah, here we are to the last one. Okay, now this looks awful familiar. It looks like something we've been doing. Yes, it does. We've got some perpendicular line segments. We've got congruent hypotenuses, and look, they share a leg, so we got congruent legs. And so I can look at this and say, well, all right, I need, if I'm going to do this by hypotenuse leg theorem, which is what it looks like, then remember, I've got three things. One, I've got to show that I've got right triangles. Two, I've got to show that I've got congruent hypotenuses. And three, I've got to show that I've got congruent legs. And so we're going to go after those three things, okay? And hopefully this one was really easy, even if it was the last one. This is super easy, okay? So I'm going to go after right triangles. So I want to, at some point, say that triangle CDB and triangle, let's see if I did CDB, I'll do ABD are right triangles. That's where I want to get to. Now, so far, the reason for that has always been, well, it's a definition of right triangles, okay, because I've always shown that there's a right angle. And if you got a right angle in a triangle, it's got to be a right triangle. So then I know the previous step, that what has to go before this has to be something about something being a right angle. So I'm going to have to say angle CDB and angle ABD are right angles. Now, I know you might think he's doing this proof backwards, but I'm just trying to show you, okay, how I build this. And so I wanted to say the right angles. Well, how am I going to say the right angles? Because I have this stuff. Because segment AB is perpendicular. Upside down T means perpendicular to segment BD. And segment CD is perpendicular to segment BD. Okay? And so that was in the given. Therefore, I know that I have right angles, because that's what perpendicular means. That's the definition of perpendicular, okay? So it took 3 steps there just to get to the point of saying I've got right triangles. Now, I'm going to go after those congruent hypotenuses. And in this picture, that would be that BC is congruent to AD. That was given. Sweet. And then I got to go after those congruent legs. Segment BD is congruent to segment BD. That's by the reflexive property of congruence. Okay, let's see here. And so with that said, then I get to say that triangle CBD is congruent to triangle ADB. And how did I get that? By hypotenuse leg theorem. Okay, well, we're done with this. What we're going to do is we're going to have a little bit of homework that we're going to start right now, and I will see you when we get back. Thank you very much.